So we're going to save the issue of rounding the bottom of the cactus until later on. The next thing we're going to address is those little points where the spines grow out of the cactus. And so for each segment of the cactus, we're actually going to have, if you recall, we're going to have those little things that I'm referring to them as buds. I know it's not the right word. We're going to have them along the tips of these ridges along the outside. And we already have a node, if we go to our node group over here, that's called segment positions. That one takes in a particular vertex. In this case, it's from the object that defines the cross-section of our cactus. And it will return a starting position and an ending position for the corresponding locations of that vertex at the bottom and the top of the segment. So we're going to use exactly the same node later with that other object that defines where those little bud points are located. If you imagine the starting position of a vertex and the ending position of a vertex and a straight line between them, we're actually going to place the buds along that straight line. And I'm going to do 4 buds along any given straight line on a particular segment. So what we're going to do is create a node. Before we do anything else, we're going to create a node that will give us a point in space, which is going to be like the starting position for a vertex. It'll give us a length vector that will tell you how to move from that starting point to the end point, and a number that will tell you how far along that line we want to be. And that way we can simply use that node and just give it different points along the line, say evenly spaced, 1/4 of the way along, halfway along, 3/4 of the way along, something like that. And that'll give us the location for the buds. So let's create a new node group. So we'll start like we did once before by simply adding 2 reroute nodes, reroute points. And just for the sake of being able to group things, add a couple of math nodes. Doesn't matter what nodes we add. Group them. And actually, let's come out and let's name this node right away. I want to call this midpoint. It's going to give us a point somewhere along a particular straight line, not necessarily the exact middle, but I'm going to call it midpoint anyway. So we come inside here. We don't want the math nodes. Let's create a little space. And let's work on those inputs first. So the first input is going to be a vector. And I'm going to call it the length vector. Right? It's a length equal to the length of the distance between the start and the end vertices. It's also a vector telling us the direction. So in fact, I don't want to call it length, I want to call it length vector. The next input is the starting point, and that's also a vector. I'll just call it start point. And then the last value is a floating point number that's going to tell us how far along that line we would like to get a particular point. And let's just call that point measure. It'll be a value between 0 and 1, where 0 means we want exactly the start point. 1 means we want exactly the end point. 0.5 means we want exactly the point that is halfway along. That's how that's going to work. And the output from this new node is going to be a vector. And it's just that midpoint. So I'm just going to call it midpoint. Again, I know it's not exactly the middle. All right, so this is an easy one to compute. We just need a couple of vector math nodes. So look up vector math node, create 2 of them. And the first one, we want to use the scale function. And what we're going to do is we're going to take that length vector and we're going to scale it down to a fraction of its length based on that point measure. And then the other one is already set to the add function by default, and that's the function that we want. And we're simply going to add that little shortened length vector to our starting point. And that's it, really. That is the computation. It's time to do a tiny bit of cleanup as usual. Okay, let's put this new node to use. It's called midpoint. We can safely delete it and we'll be able to search for it in a moment. We're going to go inside segment position. And let's bring up one of our nodes. Midpoint. There it is. All right, now what this node currently does is, we give it all these parameters about, the current tilt and centers and direction and so on for our segment, and a particular vertex from our cross-section. And it returns to us the starting vertex position for the bottom of the segment and the end vertex position for the top of the segment. And we're going to modify it so that it actually returns 5 points along a straight line between those two. A point at 0% of the way, 25% of the way, 50% of the way, 75% of the way, and 100% of the way. So let us open up the panel and just completely change, not completely, but let's change these inputs. They're all still vectors, but I'm just going to name them 0.0, 0.1, etc. All right, we can close the panel. Now, our midpoint node needs the length vector, which we don't have yet. It needs a start point, and it needs the point measure. Well, start point we have. It's the value coming out of this node right here. So we can plumb that through. Now, as for length vector, it's basically just the end position of the vertex minus the start position. That'll give us a vector pointing from the start to the end. So we can pull up a vector math node, and we can have it use the subtract function. And again, we're going to take the end vertex and subtract the start vertex. And that is our length vector for the midpoint node. Now we wanted 5 of these midpoints. I'm going to cut the old connections, and I'm going to hook this up here. Remember that that measure goes from 0 to 1, where 0 means we will get exactly the start vertex, and 1 means we will get exactly the end vertex. So what we can do now is simply duplicate this 5 times. There, so we have 5 copies. And we can wire up the same 2 inputs that we have here. Like this. And then we just specify that this one is at 0% of the way along the straight line. This one is at 0.25, which is 25% of the way. The next one is at 0.5, which is 50% of the way. The next one is at 0.75, which is 3/4 of the way. And the last one is the end point of the line, and therefore is at position measure 1. And we just plug these in to our outputs. And then we clean up the wiring, of course. That's it. That's our wiring. So now we have the start point, the end point, and then 3 points evenly spaced between them. Now if we get back out of here, we were previously using the first and second outputs. which were the start and the end vertex. But now the end vertex is actually 0.4. So let's just make sure that we plug this into the correct output. And the behavior should now be the same. And of course, there's now a tiny bit of cleanup to do. That was pretty easy. Now let's actually create a bud object. So we don't need to be in the geometry nodes window at all. And I'm going to create it at the origin, so I'll just hide the cactus for now. And let's add a UV sphere. And let's make it 12 segments, 8 rings. Let's get into edit mode, and yeah, let's shrink this so that it's quite tiny. And now the way we're going to create these spikes is fairly straightforward. Let's remain in edit mode, turn off proportional editing if you have it on like I did. And I'm just going to turn all of these top faces into a single face by highlighting them and pressing F. Just don't need the extra geometry. I'm going to do the same at the bottom. And now let's highlight faces in a kind of checkerboard pattern. After this, go to the face menu and look for poke faces. And this will add a vertex to the middle of all of the highlighted faces. And then let's select all those vertices. Just like that. Just going to jump into an orthographic view from the side and just lift everything straight upward. And then scale outward. And we're nearly done. Let's just go into face select mode, grab the bottom face, again go into a side view, re-enable proportional editing, and pull that down just to elongate this structure a bit. Just like that. And then finally, let's shade smooth. And let's name this object bud. We've got our spiky bud object, and we've got a geometry node that gives us the points, the places where we want those spikes to appear. Time to put those two things together and put some buds on some cactuses. So let's hide bud. And in fact, we can hide it from the render as well. There's no need for it to be there. We can bring back our cactus. Let's select it and return to that full screen geometry node setup, which is here. And yeah, let's go inside one segment. And let's add a few more inputs and outputs. So scroll down to the bottom of the inputs, and we're going to add one more of type object, which is the bud points object. So make it type object, and let's call it bud points. The next one is also an object, which is the bud object that we just created. Let's call it bud. And then the last one is, in the same way that we're sort of accumulating the body of the cactus as we compute the output of each consecutive segment, we're going to pool together all of the buds that we generate as well into one single chunk of geometry. And so that's going to be the final input. So it is of type geometry, and we'll just call it buds plural. And then we want the same three values on the output so that they can be wired through to the next segment in the chain. All right. Let's start by just wiring those up directly from input to output. Our segment positions node has outputs that we need for the cactus that we built so far, but it also has the outputs that we need for positioning the points where we will produce the buds. So what we'll do now is actually just make a little space and clone this node, the segment positions node. And then we want to wire all of the same inputs, except for the vertex position, but all of the same inputs from the first segment positions node into the second one, like this. Now let's make a copy of the spawn xsec node, bring it over here, and let's feed it our bud points object. Now the vertex that comes out of that is plugged into our vertex position input on our second segment position node. And let's create 4 set position nodes. And let's plug points 0 to 3 into the position inputs of each of those. Incidentally, if you're wondering why we didn't plug point 4 into a 5th, these are the points where we will have the buds on our cactus. Point 4 is the very end, the very top of the segment, and it overlaps exactly with point 0 of the next segment, so we don't need to add a bud at that point. Next, let's plug the geometry from our spawn xsec node into all of these as well. Then let's join that geometry with a join geometry node. And of course, a little bit of cleanup. So all this geometry that's being joined here is a bunch of vertices that represent all the points where we want to put an instance of our bud object. So let's grab a node that's called instance on points. And that's what's going to put those bud objects at the positions of the vertices. So we're going to plug in the geometry into the points input. Next, we need to know what instance to spawn at all of those points. And for that, we're going to use our bud object. So we need object info, and we need to feed it our little cactus bud. And check as instance. So we'll plug that geometry output into the instance input. And next, we need to know what way to rotate our bud objects. And we want to rotate them so that they point away from the surface. So what we want is, we want to know the surface normal, which is a vector pointing perfectly perpendicular away from a surface, for each of these vertices. So we're going to pull in a capture attribute node and just drop it on our geometry link. And we're going to capture the normal attribute. So let's grab the normal node. And what we're capturing is not a float, it is a vector. So plug normal into the vector input. And then we have a normal, but we want a rotation. So we want a rotation that's going to put the z-axis of our bud instance aligned with the surface normal. Well, there's a node for that. It's called align Euler to vector. We'll tell it that it's the z-axis that we want aligned. Recall that our bud object is basically oriented facing upward. And we just plug the attribute output into the rotation input. And that will compute for us a rotation that will put the z-axis in line with the surface normal. So we plug that into the rotation. Now recall back here how we used this greater than comparison and this switch node in order to completely switch off segments that shouldn't be visible yet, just to cut down on the amount of geometry being rendered. I don't know if it's strictly necessary, but I like to keep it clean this way. So we're going to do the same with our buds. So duplicate the switch node, make a mental note that the geometry that we're going to keep goes in the true socket. And we're using exactly the same condition. So we can take this pink output and use it as the input on our new switch node. Let's bring it over here. So here's our new geometry. We plug it into the true socket. And now remember over here how we would take a particular new segment for the cactus and we would join it together with all the previous segments that have been created and pass it on to the next node. We're going to do exactly the same with the buds geometry input output down here at the bottom. So just copy our join geometry node and insert it here in this way. And then plug the output from our switch node into that join, and finally do a little bit of cleanup. We've got our new inputs and outputs on our segment node, but we don't have them wired through the chain of segment nodes. So we can do that next. And then we want to combine our new buds output with our final output. So we're going to need a join geometry node. And we're going to plug in our existing cactus and our buds, and that'll be our new output. And then our overall cactus needs two new inputs. The first is an object, which is bud points, and the second is also an object, and it's the bud object. And of course that needs to be passed through to the first segment. Now we can return to our window and provide bud points as the bud points input and provide the bud object as the bud input. And voila, we've got a whole bunch of buds, but obviously they need some work. There are multiple ways in which they need some work, but first and foremost, we've made a small mistake in the geometry nodes setup. So if we go back into one segment, here where we've used the align Euler to vector node, we've plugged our captured normal, surface normal, into the rotation socket. It should be in the vector socket. And now you can see they point away from the cactus. But there's plenty more to do before these are done. Another problem here is that these normals still aren't actually correct. It's a bit hard to see right now, but if we increase the length to make the cactus much, much taller, you can see how these normals are not facing away from the surface in the way that we would expect. So we're going to go back in to the geometry nodes system and make some adjustments to the way we're computing those normals. Let's go inside the one segment node. And then inside of our segment position node, we're actually going to add a new output, which is the surface normal. And that'll be the same normal used by all of the points in the straight line. Incidentally, I don't exactly know why, in this particular instance, the capturing attribute to get the surface normal doesn't work. I think it might have something to do with the way that we're constructing the cactus based on extrusions of cross segments, and we're not sealing all of the individual segments together until the very end. I'm not exactly sure, but it's easy enough to remedy. So let's go inside, make a little bit of space, and there are 3 values that we need to compute this surface normal. We need the end center, which is right here. We also need the start vertex position, which is right here. And we need the end vertex position, which is right here. And now for a bit of math, and I'm just going to ask you to trust me on this as being the math for computing a normal perpendicular to the surface in the way that will work for our cactus. Let's add some vector math nodes. Add one, set it to use the subtract function, and duplicate it. Into the bottom one, plug in end vertex position minus start vertex position, and into the top one, plug in end vertex position minus end center. Next, copy it, switch it over to the normalize function, and connect these two. Next, duplicate that, choose the length function, and connect it here. Duplicate again, and find the dot product. Plug in the result from the normal, as well as the value coming out of this subtract node here. Next, add a math node. Set it to the power function. Make it power of 2, and rename the node to be squared. Bring it over here. Plug in the output from length. Add another math node with the divide function, and take the dot product and divide it by what's coming out of the squared node. Copy another vector math node, change it to the scale function. Use the result of the divide node as the second input, and use this value here as the first input. Duplicate it again, choose the subtract function. Output from scale is the second input to the subtraction, and the first input is the output from the normalize function. Copy the normalize function, bring it over here, connect it up, open up the outputs, add a new output at the top. It will be a vector, and we'll call it surface normal. Plug it in. As usual, we'll clean things up. Now that we're computing our own surface normal, let's go and use it instead of the one from capture attribute. So here it is, surface normal. Let's plug it in here, and that means we no longer need any of this, and we can just do the usual cleanup. And let's take a look and see how it looks. Not much of a change, but if we crank up the length again, this time we can see that now the buds do face outward from the surface, rather than at a steep angle like they did before. Now all of these buds are too big, so what we're going to do is we're going to have a scale that's going to scale them down. Notice that instances on points node here, where we told it what our instance was, where the points were that we want to place the instances, and a rotation, also includes a scale input, so we can decide how big each bud is as well. So we already have a shrink factor, or a radius value, that is, larger at the bottom of a segment, smaller at the top of the segment. Let's use that number as the value that's going to scale our cactus buds. And let's have it change as the buds move from the bottom of the segment to the top. So the bud at the bottom of the segment will use the starting radius as its scale value, and the bud at the top will use the end radius as its scale value, and the ones in between will use, linear proportional. So let's convert some of the stuff that we've got here, specifically these three nodes, into a node group of their own. So let's just duplicate them, move them up here, right click, group them, and we need 3 inputs. The first is an object, which is bud. The second is geometry, which is bud points. And the third is a vector, which is the normal. And for an output, we're going to have geometry. And let's just call it instances. We can close the panel. And let's connect our inputs and outputs. So instances is the instances output from our instances on points node. Align to vector is already plugged into that node correctly, but bud over here needs to be wired up through to the input. Next, we want our bud points input to feed all the way through to the points input on instance on points. And lastly, we want our normal to plug into the align Euler to vector. And then clean up. Okay, let's give this node group a name. And let's call it buds on points. And then let's rearrange things so that, remember these 3 nodes here are the buds on points. So in fact, let's go ahead and delete those. And now the rearrangement that I'm looking for is, instead of joining all of these and then doing buds on points, what we're going to do is buds on points separately 4 times and then join the results of that. Here goes. Let's quickly take a look. We shouldn't really see that anything's changed. The fact that we're using 4 different buds on points nodes isn't really making any important difference here. But the reason why we split it into 4 is so that we can give each one a different scale value. So, because at the moment, you have a look, all of these buds are far too big. Depending on how you like your cactuses. I like mine with smaller buds. So let's get into the segment positions node, and let's add 4 more outputs specifically for those scale values. So come down to the outputs, and let's add 4, make them all floating point numbers, and let's call them scale 0, 1, 2, and 3. Okay, now let's compute them. So we really only need 2 of the inputs from here, specifically the start radius and the end radius. So let's extend those down and over to this area, and we'll put the nodes that do the computations here. Okay, so we're going to need 4 map range nodes. We're going to plug start radius and end radius into the 2min and 2max inputs of all of these map range nodes, respectively. All right. We can uncheck the clamp checkboxes. And yeah, if you're unfamiliar with the map range node, it is going to take a minimum and a maximum value as the 2min and the 2max. And in this case, it's going to translate any number between 0 and 1 as a number between the start radius and the end radius, or the 2min and the 2max. And it'll do it in a linear proportional way. So, you know, if we went halfway between 0 and 1, we would get a value halfway between start radius and end radius. And the value that determines where on that line we are is this first one. And so we're going to set a value of 0 for this node, and then 0.25, and 0.75. And then we just plug those in as our new outputs. Okay, let's get out of this node group and come back to here. And if we're going to give each of these a different scale value, that's going to need to be an input. So let's get into the buds on points node setup, open up the inputs, and add a new floating point input called scale. Scale gets plugged into the scale input on the instance on points node. All right, let's get out of here and let's use these new scale values. And let's clean up. And let's have a look. All right, so now they shrink along with the segments, which is much easier to see when we look at the bits of them that protrude on the inside. However, they're still all a little bit too big, so let's make an adjustment for that. So let's unhide the bud object, select it, hit tab to go into edit mode, select everything. Now remaining in edit mode, just scale the bud down until the size looks like something to your liking. Like that. Tab to get out of edit mode, and then we can hide the bud object again.